So today we will start with matter in our surroundings, lesson 1. So let us understand what is matter. So matter is any substance that has mass and occupies space. So any substance like the pen in my hand, or any chalk, duster, table, or ourselves, or air, planets, etc. They are all called as matter. So matter is any substance. We are not naming the substance particularly. So it can be any substance that has mass and occupies space. So and also matter is also made up of tiny particles. So inside there is tiny particles which make up this matter. For example, we can say notebook, pen, pencil, chalk, air, planets, etc. Ourselves also we can consider as matter. So you can see that a substance that has mass and occupies space. It has mass and also it occupies a lot of space. So wherever I am standing here, I am occupying some amount of space. So even you can see that I also have mass. So mass is measured in kilograms. So what is mass especially? It is the number of atoms present in the substance. So you can see that mass is the number of atoms present in a substance and it is measured in kilogram, and this mass doesn't change wherever we go or wherever we move the objects or the substance. That is with respect to the matter. So let's move on to characteristics of matter. We know now what matter is. Matter is a substance or any substance that has mass and also occupies some amount of space. So we should understand what are those characteristics that makes up this matter. So they are continuously moving. So matter doesn't stay in one particular place, they continuously move. They have space between them. They have space between them and they attract each other. So what are the characteristics of matter? Matter are continuously moving, they have space between them and they attract each other. So when we take attract each other, we get the simple or easy thing in our mind. Example is iron and magnet. Magnet attracts iron. So in depth we will understand the characteristic of matter. So let's write the first characteristics. So we already have seen that they are continuously moving. So let us take an example, like take a beaker that consists of water in it and leave it undisturbed. So leave it undisturbed for a while so that the movement of the water stops completely. Then you need to pour a drop of ink. So what happens here? So you can see that slowly the ink starts getting inside the water and there is a movement of water when a drop of ink is added. So the matter where you can see the water and drop of ink is a matter here, and you can see that water when it was totally undisturbed was not at all moving, but it made it to move again after a drop of ink is added. It is because of kinetic energy it possessed. Kinetic energy it possessed. So what is kinetic energy? That energy that the particle or the matter has obtained by the movement. So kinetic energy is the energy obtained by motion or movement, or movement of a particle. So you can see that the first characteristic states that the matter is continuously moving. So you can see with an example we have seen that we have a beaker of water and we left the water to be undisturbed for some time. Then we add a very little drop or 1 or 2 drops of ink to it, and you can see there is a movement of water as soon as a drop of ink is poured into it, and this movement is, so they are continuously moving, that is the particles inside the water molecules are started moving or have started moving, and you can see this is because of the kinetic energy it has possessed, and the particles inside has possessed the kinetic energy by the movement of the particle once the drop of ink is dropped or put into it. So next example we can see that example is same beaker we will take, then we will add sugar to it and heat it, or we will add sugar to hot water. So you can see that as the particles, when they become hot, the water is hot, the particles inside the water molecules are continuously moving because they have, the temperature is increased, and when you add the sugar, it continuously starts moving along with the particles of the water, and there is that the sugar gets dissolved very easily than the cold water here. So next, so we have seen the first characteristics of the matter. Second one is they have space between them. So now our big question is how to know that matter has space in between them. So again we will have an example. So we will take a beaker of water. So here this time what we will do is, so we will mark the level of water. Mark so this level we are marking because it will help us in further studies of the experiment that has been explained here, that now we are going to add either sugar or salt. So let's take an example again. We will take sugar. We are adding sugar. We dissolve the sugar. Dissolve some amount of sugar, and again we will measure the level of the water. So it's really astonishing that we can see that the mark where we had put the level of water, the level of water has not increased. So level of water has not increased. So now the question arises, usually in our logical thinking we think that once we add sugar and dissolve the water, after some time or after getting dissolved completely, you can see a little bit of water has been totally increased, but it is not the fact. Why? Because there are intermolecular spaces in between these particles of water. These spaces are filled by the sugar. Hence, whatever the space is available in the water, so that is getting occupied by the sugar and it dissolves along with the water. Hence, there is no increase in the level of water. So we can come to know that whatever space is found in the water, that has been occupied by the sugar molecules. So you can see they have space between them. So what was the first characteristics? Matter are continuously moving. Second one, we had seen that matter occupies space. And third one, we will see that they attract each other. So now how do we know that they are going to attract each other? So have you seen now a tap of water? You might be seeing a tap of water tap. Just observe in your house, if you have, all of you must be having the water tap in their house, but you might have sometimes noticed that when you on the tap, you can see a gush of water here. So keep one of your fingers, that is any one of your fingers, in between the flow of the water. So in between the flow of the water, you can see that there are two ways that forms. Your finger is in between, and you can see that the water has taken off two different ways, but once they pass through the finger, they come again attract each other. So that is known as matter or substance which has mass and also occupies space attract each other. So another example we had already taken was example of the iron and magnet, wherein magnet attracts iron, and also you can see that take an iron piece and hit hard with a hammer. After some time you can see that it doesn't break, but it might change its shape. Why? Because they attract, because the molecules inside the iron piece are attracted to each other and they are compressed or totally intact. Because they are solid in nature, they are intact. So they attract each other. That is, matter attract each other. So characteristics of matter, that they are continuously moving, they occupy space and they attract each other. So now we'll move further and see that states of matter. You might have already studied that there are three different states of matter, that is solid, liquid and gas. But along with this, we have two more states of matter, that is plasma and Bose-Einstein condensate, which is not much important to this year, but later stage or at the end of the lesson we will see in detail about the plasma and Bose-Einstein condensate. So let's come to the solids. Solids, as in the figure you can see that the particles are tightly packed and there is no space in between, there is no intermolecular space in between, and force of attraction is more here, and you can see that they have a definite shape. Solids have a definite shape. Have you seen that chairs changing the shape or table changing the shape? No, you cannot see that, because they have definite shape and distinct boundaries. They have a particular boundary where they stay or the area where they stay. So you can see that they are rigid or hard. So you can see incompressible means compressible, like eraser, rubber or any other thing. If you compress, the size reduces. But here you cannot see that. The solid doesn't change, or it cannot change its shape, and it is incompressible and it has a definite volume. So volume also will not change. So example, table, chalk, chair, etc. So next, coming to liquid, see the difference between the drawings here. The particles where solids, their intermolecular spaces are very or minimal, or there is no intermolecular space at all. You can see in liquid there are few intermolecular spaces and force of attraction is lesser with compared to that of the solids. So here you can see that they do not have a definite shape. Water doesn't have a definite shape, and they do not have a definite boundaries. They do not have definite boundaries. So because it is fluid and they can flow, they can continuously move from one place to another, and they are low compressible. So here you can see that it is not compressible. As they have a little bit of intermolecular spaces, they can be quite a bit compressed, and they have a definite volume. How you can say that water has a definite volume? So you can see that you pour the water in a bottle, it takes the shape of that particular bottle. You pour the water in a pot, it takes the shape or the volume that gets adjusted to that particular pot. So you can see that it has a definite volume. So your example is a jug of water, a glass of water, etc. So when coming to gas, compared to solid and liquid, they have more intermolecular spaces. You can see that intermolecular spaces, particles are few and there are a lot of intermolecular spaces, and force of attraction is very less among these. So they do not have definite shape. So you can see that oxygen, carbon dioxide and all, it is freely moving in air, and you can see they have no definite boundaries. You can see everywhere. You are not able to see, but you are able to sense it, that they do not have a definite boundaries, and they are fluid. Fluid means when you can see that, for example, take an example like you are boiling the water and it reaches a boiling point of 100 degrees C and it turns to vapor, and you have closed a lid over the pan where you are heating the water, and you remove the lid. So you can see that the gas or the vapors escaping from the pan what you are used for boiling the water. So hence the fluidity is more here, and it is highly compressible. So highly compressible because of the intermolecular spaces. This space can be used for compressing the particles that is inside the gas, and you can see that there is no definite volume. For example, liquid petroleum gas and CNG, that is, you can see that these gases have a particular fluidity only, and rest of it doesn't have any shape, or it doesn't have any boundaries or any different shape. You can see even in compressed natural gas. So these are the states of matter, that is solid, liquid and gas. You can see that the first thing is solid has a very less intermolecular spaces, and the force of attraction is more here. It is intermediate spaces. There is a quite very less amount of space in the liquid, but they have a very less or intermediate force of attraction, and you can see that there is more intermolecular spaces and the force of attraction will be very less. So next we will see the change of state of matter. So you have seen what are solids, liquids and gases now. We will understand how the solid gets changed to liquid, liquid gets changed to gas, or it is reversing, that gas to liquid, liquid to gas. So for that we need to understand change of state of matter. So here you can see that change of state of matter can be of two different types. How we can change the state of matter? First thing is by changing the temperature, and the second is by changing the pressure. So for example, we will take that a solid example, that ice. So ice, we keep it in normal temperature. After some time you can see that it turns to water. So this water we will heat it, and you can see that after some time vapors come out and it forms a gas. So here you can see that ice, a solid, on keeping to or removing out of the refrigerator, you can see that it takes the form of a liquid or water, and this water we heat it. You can see that after some time there are vapors that is coming out and it is the gas. So how we are going to reverse it? So reversing the temperature. So what happens when we reverse the temperature? So let's imagine that we had put the ice in a beaker or a pan. So now the ice in the beaker turned to water, we heated it and it turned to gas. So we will leave it for some time for cooling. So we will leave the gas, or after heating we will leave it for cooling. So on cooling, the gas will again retain its liquid form or change to water. This water on freezing, will turn to ice, which is known as solid. So you can change the state of matter by changing the temperature. So here we have seen that how an ice from solid it changed to water, and from water it changed to gas, and reversing it, that is from gas on cooling, we found that the gas or the vapors cool down to form water again, and on this water was again freezed or put into refrigerator to see that it turns into solid, that is ice. So now we will see the second form of change of state of matter by changing the pressure. So for example, we will see that. So we'll take an example of a gas. So pressure is given to the gas and it gets compressed. So we have already seen that gas has lot of intermolecular spaces. You are compressing it. Okay? You are compressing it. So on compressing, what happens? You will have more particles here and less intermolecular spaces, wherein this gas changes to liquid state. Okay, this liquid, on applying more pressure, you can see that it will attain solid state. So you can see that a gas is compressed, totally compressed because of the intermolecular spaces and very less force of attraction. You can see that the gas has been compressed, and on compressing you can see that the space has been reduced, and you can see the particles are more, and it takes the form of a liquid, and from liquid you are again compressing it, and there is very minimal or no intermolecular spaces, that turns to solid. So now let's reverse the process. So let's take example of solid carbon dioxide. You are giving pressure to it, but here it doesn't turn into liquid. It doesn't turn into liquid, but it turns to gas directly. So in general we have seen that changing of state of matter by changing temperature, how we can change our state of matter from solid to liquid and liquid to gas, and reverse, and by changing of pressure, what happens when the pressure is changed from solid to liquid, liquid to gas, and the reverse process. Now we will go one by one stating what happens by changing the temperature, what are all involved in the change of state of matter with respect to the temperature. So first, by changing temperature, first is melting point. It is the temperature at which a solid melts from liquid at atmospheric pressure is known as melting point. So we have started with the two different types of change of state of matter in detail. That is, there are two different types, that by changing the temperature and by changing the pressure. And by changing the temperature, first point is melting point. Melting point is the temperature at which a solid melts to form liquid at atmospheric pressure. So example we will take now. So you have an ice. So you need to heat it to melt, to form liquid. So ice temperature will be always 0 degrees C. So you can see that in a beaker you have ice. So you have an ice in the beaker and you start heating it. Initially you will check the temperature. Initial temperature is 0 degrees C. Then you see that 50% of, after heating for some time, 50% of the ice has been melted, and then again you will see the temperature. But again you can see that it is after 50% of heating. You can see the temperature remains the same and it is 0 degrees C itself. So you might be imagining that how it is possible. It's already melted for 50%, but it is not the case, and it is that totally the ice needs to melt so that the temperature starts rising. The temperature will reach its maximum. It is related to latent heat of fusion. So why this temperature of 0 degrees is not increasing is due to the process of latent heat of fusion.